Hi everyone, Mrs. Spatola here, going over Unit 4 study guide for our factors review. If you take a look at the top, number 1, here's a list of your prime numbers, so make sure you include them all. The next one for number 2 is a list of all of your composite numbers. Yes, I barely got them all in. There you go. So take a look, make sure you have them all. A composite number is a number that has more than 2 factors. Remember, a prime number is a number that has exactly 2 factors, one and itself. Numbers 3 through 11, just double check. Look at your prime and composite numbers. And there you go. Moving on down, looking at number 12, 13. This one here this should actually be number 14. This is number 15. A couple of little corrections here. And make sure that you know the divisibility rules for your numbers. You will be seeing that on your next assessment, which is coming up real soon. All right, let's go on to the next page. Again, continuing with divisibility rules. For number 15, they wanted to know how many different ways I could group students. Now, interesting with this particular one for number 15, when we're looking at 15, we notice that it is a T-chart. But for that particular question, you want to make sure that you go 1 group of 24, 2 groups of 12, 3 groups of 8, 4 groups of 6. But then you can turn it around for that particular question. Can you have 6 groups of 4? Sure you can. Can you have 8 groups of 3? Of course. 12 groups of 2? Yes. And finally, would you have 24 groups of 1? I would include, but not normally, unless you are working independently. All right, let's move on to number 16, factor trees. Factor trees, remember, prime factorization. What you're looking to do, and remember, this unit is all about number theory. Prime factorization is the process of representing a composite number as a product of prime numbers. Now, product, you will see this again really soon. You need to know that a product, mathematically speaking, is the answer to a multiplication problem. And when we talk about numbers that we multiply together, those are called factors. Good. Factor times factor equals product. So the first step here are the steps. So let's just look at it this way. I don't know why these numbers picked out like this, but if we just go through and correct these, step 1, pick any set, that's 2, of factors for that number. Number 2, keep factoring the numbers until only numbers left are prime numbers. Next one, circle, step 3, circle and list all the prime numbers. Step 4, list the numbers in order from least to greatest. And finally, number 5, write your answer in exponential form. So if we look at number 16, what is the prime factorization of 36? Notice I picked 6 times 6 to start. You can pick any 2 numbers. Just be careful that when you're looking at factors that you don't pick the sum. I noticed, so for example, for 36, it's 6 times 6. One of the things that I've noticed is that students, instead of putting 2 times 3, they're putting 3 times 3. So instead, in their head, they're thinking addition instead of multiplication. So be really careful. So with this one here, it's 2 times 3 times 2 times 3. You write them all out, 2 times 2 times 3 times 3. And finally, as we saw in a previous video, tidy them up. We put them in exponential form using an exponent, 2 to the second times 3 to the second. Let's continue. Again, a couple of more practice problems. Write the prime factorization. We have for 32, that is listed here. So 32 is 2 to the 5th power. And number 18 is the prime factorization of 48. When you go ahead and break it down, your final answer is 2 to the 4th times 3. Next section for 19, 20, and 21, T-charts. The T-charts, factoring numbers and T-charts, the process of using a chart to identify the factors of a number. Always begin with 1 and the number itself and go through all of the numbers. Now, looking at number 19, one of the things that Mrs. Gelderman would say is you want to go down the elevator and then back up the elevator. So basically 1 times 48. Does 2 go in? Yes. Does 3 go in? Yes. 4 go in? Yes. 5? No. And then 6. Once you get these numbers here at the bottom that are close, that's it. Once you work your way back up, you know that you're finished. Please, please, please use your calculator. If you're good with your facts, just double check with your calculator. And number 20 and 21 are listed here. And lastly, at the bottom, just a little review that states the greatest common factor, numbers that have the greatest number that two numbers have in common, two or more numbers actually. And there are two methods to find the GCF using the T-chart, using prime factorization. Although we introduce prime factorization, please do not stress over that method. A few students do like that, my preferred way as well. However, just make sure you understand how to find it using T-charts, and that will work well. Finally, the GCF will be used to simplify fractions and to find the least common denominator when adding and subtracting fractions with unlike denominators. The remaining in this unit is to simplify fractions, and then as we move on in our next units, we are going to get into more fractions. Isn't that wonderful? So let's take a look at what we have on our workbook study for today. Greatest common factor using a T-chart. When you are looking for the greatest common factor using a T-chart, you are comparing two numbers, and step by step it is listed here. First you make the T-chart, then you look for common factors, and you could circle up the numbers or you can make a separate list. Then finally you circle the greatest common factor. That would be the biggest number that both have in common. So for number 2, find the GCF of 32 and 48 using a T-chart. You're going to list all the factors. If you need additional help or additional support, please go back and look in Unit 4 in your Google Classroom to see where is that lesson that I really need to rewatch that video for. These videos are designed for you to be successful. So if there's any questions that you have, of course you can always reach out. However, go back and look in the videos and in your workbook because all of the information it's right there at your fingertips. Moving right along, GCF using prime factorization. We touched on this in class. I am not going to make you responsible for this one, so you can go ahead and cross out number 23. You are not responsible for that. Also, in speaking with 7th grade teachers, I've learned that they do not find the greatest common factor using prime factorization, so we're just going to move on. Let's go down to the next section, which is equivalent fractions. Equivalent fractions are fractions that name the same amount. You can use either multiplication or division to find an equivalent fraction. So if you have to write fractions that are equivalent, remember, you've heard this in elementary school, whatever you do to the top, you have to do to the bottom. Here is a picture of a fraction wall. So if you just want to get an idea of some of the fractions that are equivalent, this is also in your workbook on a previous page. If we look at the first example here, 4/8, notice the numerator and denominator are both divided by 4. Whatever you do to the top, you have to do to the bottom. They are equivalent. 4 is the greatest common factor of 4 and 8. So the GCF of 4 and 8 is 4. When you divide by the greatest common factor, it gives you your final answer of 1/2. And notice you're only dividing once. Now, could you divide? The questions come up, Mrs. Patola, can you divide by 2/2? Well, you could, but then you have to make sure you do it again. So for our purposes, you want to make sure you find the GCF first. Yes, it takes a couple of more seconds, but you will be sure to do a good job and get it correct if you find the GCF first. Now notice here's 2 more examples here. Finding equivalent fractions. Notice 3/4. You're multiplying by 3/3. So whatever you do to the top, 3 times 3 is 9. You have to do to the bottom. You're multiplying by 3 again. 4 times 3 is 12. And then the next example is you're multiplying by 4/4. Now, one thing I want to bring to your attention. How do you check? This is how you check. You should be writing this in your workbook. How do you check to see if something is equivalent? Check to see if equivalent. Write this down. How do you check to see if something is equivalent? You can check the cross products. So you cross multiply, here are the steps, and I'll be checking to see if you have this in your workbook, cross multiply to see if it is in your workbook. So when you cross multiply, if the cross products are equal, write this down, cross products are equal, then you know that the fractions are equivalent. So when your cross products are equal, they are equivalent or equal, okay? Equivalent or equivalent. Okay, so for these here, 24, 25, and 26, you're going to write 3 fractions for. So you're going to write 3 separate fractions for 8/12. You can divide if you want, you can multiply if you want, whatever lends itself, and you're going to write 3 separate fractions for each fraction that's listed. You're going to be writing equivalent fractions. Finally, on our last page, simplifying fractions, a fraction is in simplest form if the numerator and denominator have no common factors except for 1. So here are the steps here for simplifying fractions. Step 1, find the GCF. Step 2, divide the numerator and denominator by that GCF. So a great example that's given here, all you have to do is follow along, is divide. So for 12 and 18, the greatest common factor, and you can do it using T-charts, is 6. What is the largest number that 12 and 18 have in common? That would be 6. And then you're dividing the numerator and denominator by 6. Now, the next one, it says, for 27, 28, 29, and 30, it says put the following fractions in simplest form. So for number 27, you're going to find the GCF. So what I would do is you have the top boxes or even on the side. So for 18 and 54, make your T-charts. Go ahead and do that. Find the largest number that's in both. Please use your calculator. And then you're going to simplify all of these fractions here. Number 31 is evaluate. You're going to solve. You will definitely be seeing this for sure on your assessment, something to this nature, so make sure you did a good job with that. Number 32, I'm going to say cross out. You don't need to do this one. It says translate, solve, and check. We haven't done that yet, so we're going to actually just skip this for right now. I might give you something to translate, but we'll go over that in class. Next one's at hockey practice, Coach Al wants to make equal teams. Tell whether the following numbers will work. So yes or no. So for that particular question, they are asking you which numbers are composite. Because in order to make equal groups, you have to have composite numbers. If the numbers are prime, that will not work. So be careful. They're asking you yes or no, are they prime or composite? And finally, number 37, you will definitely be seeing this one as well. You have 36 gold charms and 24 silver charms to put on your bracelet. What is the greatest number of identical bracelets you can make if all charms are used? For that one there, you want to find the GCF, and that's what it's asking you. You definitely want to find the GCF. Alrighty, so for today, that's a wrap. Please make sure you go back in your workbook and check your Google Classroom to see if there are any additional items that you need to do for today's lesson. This is Mrs. Patola wishing you a great day. And remember, always, always be kind.